Here are our final set of formulas that we are going to learn in our trig work in pre-calculus this year. There are sum to product formulas, and there are also product to sum formulas. So we're going to add these to our list of identities and formulas that we need to know in order to work with our trig equations. And so let's just get these in your notes and work a couple of examples, and then we'll practice some more in class. So the sum to product formulas look like this. There is a sine sum formula and difference formula that turn, if we take this is not the angle sum, this is the whole function sum. If I take the sine of angle measure u plus the sine of angle measure v, then it turns into this product, 2 times the sine of u plus v over 2 times the cosine of u minus v over 2. If I have the sine of u minus the sine of v, I get 2 cosine u plus v over 2 sine u minus v over 2. The cosine of u plus the cosine of v is 2 cosine u plus v over 2 cosine u minus v over 2. And finally, the cosine of u minus the cosine of v is negative 2 sine of u plus v over 2 sine of u minus v over 2. So just pause the video, write these down in your notes, and we'll work an example. So this says find all the solutions in one revolution. Here's our notation that we don't need a general solution. So no 2 pi k kind of idea. Find all the solutions for the sine of 5x plus the sine of 3x equals 0. So here is u and here is v. In this case, u is 5x and v is 3x. So look back in your notes to the sine of u plus the sine of v, and this is the formula we are going to use to write this as a product so that we can set everything equal to 0 and find our solutions. So if u is 5x and v is 3x, we know from the formula it's 2 times the sine of 5x plus 3x over 2 times the cosine of 5x minus 3x over 2. So when we add these together, we have the sine of 8x divided by 2, so there's the sine of 4x, and we have the sine of 2x divided by 2, so we get the cosine of x. So now we set each one of these factors equal to 0. First of all, I can divide through by 2, so I'll have the sine of 4x times the cosine of x equals 0. Dividing 2 over here makes the 2 go, 2 divided by 2 is 1, 0 divided by 2 is 0. So I set each one of these factors equal to 0. And so the sine of 4x equals 0, sine equals 0 when the angle measure equals 0, or when the angle measure equals pi. Then I divide both sides by 4. So I get x equals 0, or x equals pi over 4. The 2k pi doesn't need to be there. That would be for the general solution. So don't put that in your notes. X is either going to equal 0, because 0 divided by 4 is 0, or it's going to equal pi over 4 for this factor. I set the other factor equal to 0, and cosine equals 0 at pi over 2 and 3 pi over 2. So you can see it's just a matter of really identifying u and v and plugging that information into those formulas and then finding each factor and setting it equal to 0. Now that was sum to product formulas. There are also product to sum formulas. So if I start out with a product and I want a sum, then I would use these formulas. And so if I have the sine of u times the sine of v, and I want to get a product or a sum or a difference, then I would use this formula right here. I won't actually read them to you. I don't want to take up that much time on the video. You can pause it, you can write them down, and we'll work a couple of examples so you can see how to use these formulas as well. So this says rewrite the cosine of 5x times the sine of 4x as a sum or a difference. So if I have cosine of u times the sine of v, then I'm going to go back and look at these formulas, and here's the cosine of u times the sine of v, so this is the formula that I'm going to use. I'll need to recognize what u is and need to recognize what v is so I can plug those into this formula. So I have 1/2 the sine of u is 5x, V is 4x. So I just plug those values in and then clean them up. So I wind up with 1/2 the sine of 9x minus 1/2 the sine of x. This 1/2 has been distributed over this set of brackets here. So pretty straightforward. It's just a matter of identifying what u is and what v is and plugging them into that formula. All right, so that's it. Come to class next time and we'll practice these product to sum and sum to product identities.